Hello, I'm Joshua Laughlin.
And I'm Jason.
And this is Cruising the Cosmos. Thank you for watching. This is a special presentation. We have Will Young, President of the Astronomical Society of Southeast Texas, and we're going to be talking to you about star parties.
So, Will, what is a star party?
Well, you know, it's a party of stars.
Yes.
And other things like that. Now, you know, it's a chance for amateur astronomers to get outside and set their scopes up. You'll see a lot of scopes pretty similar to this. And we get out, we see what's up in that particular season, whether it's summer, spring, fall, winter, whatever. And we check it out. We check out the moon, Saturn, Jupiter, you know, whatever planet happens to be in the sky. And, you know, it's just a chance to put your telescopes to use, honestly.
Mm-hmm. Well, I know I've been to a couple of them. Josh has been to a few of them as well. Obviously, you're a seasoned veteran.
Yeah, well, yeah, I've been to more than my my fair share, for sure.
What can you expect, though, say, if you don't have a telescope? Because I know I didn't have one for quite some time, and I was really interested in astronomy.
Well, the thing about it is you know, amateur astronomers are very open and nice guys. You know, they're very accepting. You know, if you don't have a scope, more than likely the guy who does is going to find something cool and ask everybody around if they want to come and have a look and take them up on it, because you know, if somebody offers you to, you know, check out an object through a scope, it's probably going to be cool, and that probably means that they're okay with you looking through their scope. So you don't have to have a telescope or binoculars or even a star chart. You can just go to a local star party and you know, have a fun time enjoying what they give you as a tour almost.
So, what can I expect? Like, what do I need to know? If I've never been to a star party, what do I need to know?
You need to know what season it is and how to dress. You don't want to go out to a star party in the middle of December, you know, with shorts, obviously, unless you live in the Caribbean. You'll want to dress appropriately, bring bug spray, you know, some water, some snacks, things like that. Keep your mind energized, because you know, you have a tendency in the dark to want to go to sleep. So you will get tired out there because you're, you know, surrounded by the darkness or whatever. Lawn chairs, blankets, if you want to just lay back and look up and maybe catch some meteors or something like that. And then just bring a curiosity to explore space.
Well, what's the deal with the red light versus using like white lights and other lights like that?
Well, I actually have one. This is a Celestron, and you can see that it's dimmable, so I can dim it out or I can brighten it up. And you know, the red light, it's part of the spectrum that isn't very high in energy. Your eye is susceptible to the light, so it can see very well at night with a red light, but it doesn't wash out your night vision. I mean, it's the black room concept. If you've ever seen a black room on a TV show, it's a red, you know, a red lit room, and you know, it just saves your night vision, because that's important if you're going to look at a star chart and then immediately look up into the blackness of space. You don't want to have a you know,
Headlights staring at you.
yeah, you don't want to do that. You know, and to be honest, anybody that's ever been to a dark place and has seen a bright light come on knows it's not painful, but it's annoyingly painful, to where you're like, whoa, you know.
And it messes you up for a good amount of time too.
Yeah, at least 30 seconds. If you close your eyes for 30 seconds, you can get your eyes pretty much dark adapted and start viewing. I think something like 5 minutes to get fully dark adapted. Once your eye finally, rests out at the full dilation or whatever. So red lights are a key. You never want to bring a white light flashlight until the very end of the star party when everybody's packing their gear up. We're going to hit it with headlights, Q-beams, whatever we had to make sure nobody dropped any lens caps or mirror covers or anything like that, because that's, they can add up and be kind of pricey sometimes. So, and people do forget things. So that's just that's the nature of the beast right there.
So I guess now that we know what to bring to star parties, what to wear, a little bit of food, a little bit of places to sit, and if you have a telescope, bring that. But what about binoculars? Can you see anything good with binoculars?
Absolutely. Some of the coolest views you can have can be through binoculars, because you don't necessarily have to know exactly where to point it. You can just grab a good pair of binoculars and then just start scanning the sky, and you're going to run across something that's going to pique your interest, whether it's a cluster of stars or some nebula that you didn't know was out there, and then you run across it in your binocular field of vision. It happens all the time. I've seen meteors cross my field of vision in binoculars, just laying flat on the ground with the binoculars sitting on my face and letting gravity do all the work, and then straight through the eyepieces came a meteor. So yeah, there's all kinds of little weird things you can see like that in the sky. Satellites, you'll see them cross. The Milky Way, so if you go out at night in the summertime and you just have a pair of cheap binoculars, 10 by 50s are a common size and power, you can scan the Milky Way and just never run out of interesting things to see. There's going to be so many stars in your field of vision that you actually get jaded to what you're looking at. You don't, after a while, you don't understand that you're just looking at a sea of stars. And it can get like that in a telescope too, obviously, but you're much more magnified toward your object. It's much closer to you.
And I think the first time that I went to a star party was we went to what was it? Saratoga.
Saratoga, yeah.
And I admittedly left something of my telescope that wouldn't make it work. And the first time that we got to look through it was we looked through some big old binoculars, and we saw Andromeda, right?
We saw Andromeda.
Through the binoculars, and that was pretty amazing.
That's a great binocular object because it is so big.
I didn't think that you'd be able to see something that far away with binoculars. So
2.5 million light years,
I mean, if all you have is binoculars, bring them. I mean, you'll definitely find something that you can see in those.
Yeah, and I mean, the problem with binoculars, like the pros are out the roof with the pros, but the cons are they're sometimes bulky and kind of heavy. They're hard to hold in one spot to really study an object.
Right.
They're more wide field. Instead of being more focused like a telescope. I don't want to knock it over. But there's a different vibe. You've got two eyes looking at the same thing versus one eye with the other one. You're either holding your eye or you're clenching it like that. Yeah, and I've worn eye patches before just so I can keep both eyes open and then not have any light. Because then your other eye has to strain less at the eyepiece, which can help you see way more detail. And when you're in light polluted skies like in Port Arthur, Groves, Beaumont, you have to have every ounce of detail you can have to get every little nuance out of it.
So can you tell me what the difference is? Like, what is the purpose, or what can you tell me about dark sky versus urban skies?
Well, there's a lot to be said for some unpolluted skies, that's for sure. Naked eye, if you could magically transport yourself to the middle of the ocean and look up, you're going to see immediately so much, like so many stars, so much other interesting things that you'll lose the constellations. Even the most seasoned constellation hunter, I know most of the Northern Hemisphere constellations. When I go out to El Dorado, which is a place that A.S.S.E.T goes for dark sky star party, I lose some of the dimmer ones like Aquarius and Libra and some of the more dim constellations, Draco. You'll lose them because the stars that are around them are so much brighter. So you're looking for the dim stars, to make up your constellation. Because a guy like me, I've grown up looking through light polluted skies anyway. So it's a different dynamic out there in the dark. But when you put a telescope, let's use Andromeda for example, in a place like that versus here in the city, you're going to see probably like double the amount of detail. You'll see way more of the nuances inside the galaxy, what we call modeling, which is actually pockets of stellar formation and clusters inside that galaxy. You'll see that with more detail, more brightness, and it just overall, I mean, you're going to see, you'll see the object here in a light polluted sky, but you'll be missing part of the picture. The background will be nice and black, unlight polluted place. So there's a lot to be said.
Oh, I noticed, as the club, we try to do these star parties at least twice a month. If the
Weather
sky,
permitting.
if it permits. Can you tell us a little bit about the places we meet up and when?
Yeah, well, A.S.S.E.T has a dark sky site at Martin Dies Jr. State Park. The staff there are fantastic. They love for us to come out there. Our park ranger Taylor is always there when we need him with the info we need. And so we just we'll set up our scopes right near the waterfront basically. So it's a good view even all night. Even if the skies aren't that great, we still have a nice watery vista to enjoy. That's where we do our dark sky star parties. So that's once a month every new moon. So whatever Saturday or Friday is closest to the new moon of that month. If we don't have an out-of-town star party, that's where we go. For the first crescent, which would have been tonight, on a Friday or Saturday, with the moon basically at first quarter, we will meet at Claiborne Park, which is not too far from Vidor or Beaumont, whichever way you're coming from. A little bit less detail in the skies there, a little bit more light pollution, but it's a chance for us to get out with a partial moon and have the general public not have to drive an hour and a half, 2 hours to go view. So those spots are nice. We'll start sidewalk astronomy coming up pretty soon. It's a project the club is working on, and so we'll be just setting up telescopes like this in parking lots, sidewalks, wherever whoever will have us, and we'll start showing the public the moon or some of the bright planets.
Awesome.
Yeah.
Well, what can you tell us, since, like I said, this is for the club itself, new members, anyone that's, potentially viewing this, that is now finding out about the Astronomical Society of Southeast Texas. What can you tell them about the club? What can they expect? Why should they join the club?
Well, we're an active, extremely active group. The guys in the group, when I came in 2009, are just super nice. Everybody's super nice. Everybody is willing to show you the ropes from the ground up. We all have equipment that it's fairly nice. Guys have way bigger and better telescopes than I do in the club, so that's I look up to them as far as hey, I see this galaxy like this, but let me go see what it looks like in Howard's scope or Roger's scope or whoever's scope is out at the time. And it's just a great group of friendly guys. They're all really open and they'll share any amount of information you need. Whether it's binoculars, dark skies, light pollution. We have guys that are experts on galaxy hunting and things like that. And we have a couple of master observers in the club who have gathered 10 or more awards from the Astronomical League, submitted all the information, and got back their awards. So that's a hefty goal to meet, 10 awards, because an award can take you about 2 years, depending on the award. I mean, the Herschel 400 award is 400 objects. They're galaxies, open clusters, dim, faint little things. And 2 guys in the group, or maybe even a couple more, have done that program. It's a big program.
It's an impressive list.
Yeah, so these guys know what they're talking about, and they're willing to share everything with you. And we have indoor meetings once a month, second Friday of every month at the planetarium in Beaumont, 7 p.m. And we talk about what's going on in astronomy, the news about NASA, or what was newly discovered, what asteroid or comet is passing by us this week, is grazing planet Earth, you know, potential Earth killers. You know, we talk about what, you know, people are doing as far as their observing goes. People will report back. We have a newsletter that's really great information. And we have a great website. Of course, you don't have to be a member of the club to go to the website. And we have a wealth of information on there, great links and things like that to take you to sites that will help you, you know, do astronomy better for sure. And it's just a great group if you're dedicated to astronomy, or even if you're just getting into it and you don't know what to do. It's good to find a local group of individuals that know what they're doing and can break it down for you to show you how to do things.
Because I know I'm fairly new to astronomy. Josh is as well. And we've learned a lot since we've joined to the club. I mean, I can tell you,
Oh man, you.
maybe like a year ago I wasn't even familiar with how to use a telescope, and now I can find a lot of things up there.
Yeah, and that's how it works.
Working on the SCA projects and things.
Yeah,
Telescope.
yeah, you have a better mirror than me, I think, in some respects.
And also, don't forget free snacks at the meeting.
Yeah, free snacks. How can you beat that?
So it's worthy to note that the club itself is part of the Astronomical League. And I remember you saying at the meeting that you and Terry, was it, or Howard?
Yep. Terry, yep.
Actually started working on a new award for the league.
Yeah, we're gonna. We got the green light this week. We're putting the final touches on everything. The award is basically written, and the details are laid out. And so when we start, you know, taking submissions for this, people will be applying for supernova hunting. Basically, is what it is. And you know, if you can do it two different ways. You can do the award telescopically, which a lot of the awards in the Astronomical League are based on visual astronomy, or you can image it, which is a little bit different process, but it's totally doable by guys like, you know, us, even without the equipment, because they have all these telescopes online that you can go to, itelescopes.net, I think Light Buckets, and there's a couple of other guys out there that have telescopes in like New Mexico and France and Australia, and you buy time on those telescopes, and we're talking $15,000 mounts, $70,000 telescopes, $5,000 cameras, and you're using maybe $15 for an hour's worth of time.
Relatively cheap.
Yeah, it's extremely cheap, and so like you get the notification there's a supernova in, let's say, M85 or M81, and so you'll go to your little website with your little account, sign on to a telescope, take a couple shots of it, get the data back, compare it with a picture of that same galaxy a few months back, and it's not going to have that supernova star there. And then you mark the supernova, you label all the information we asked for, and you're done with that one. And then you get several more, and these things happen quite often, actually.
There's a lot of galaxies out there.
There's a lot of galaxies out there, and even more stars inside those galaxies, and they explode all the time. It's actually a pretty rare event what actually happens with a Type 1A supernova. You have a white dwarf, which is a star that used to be alive a long time ago that blew off its shells and collapsed. And then another star just happens to be unlucky to come too close, and then it starts basically pulling material off. Yeah, it's pretty unlucky because both stars basically end up dying in the exchange. Sometimes it just depends, but it's a really cool aspect of astronomy. It's never been done before in the Astronomical League, and so they're excited about it. We're excited about it, and I'm just hoping, you know, whoever has award number 1 is gonna. I mean, they got a hefty order of galaxies to do their data and deciphering what they've done.
Well, make sure you do it on one of our commission paychecks so I can pay for all this telescope time.
Sure, yeah.
And just cheat it and just pay for it that way.
Oh,
Won't pay my way into an award.
There you go. You can buy awards. I mean, that's, you know, it's like Taekwondo.
That's right.
Just pay for the belt.
That's right.
To work for it.
I mean, I got a Super Bowl trophy in my house from eBay.
Now the ring, that'd be impressive.
Was there anything else you wanted to add?
No, I think we about summed everything up. Huh?
Is there anything else you would like to address to the people?
I mean, just get out and observe. You don't need a telescope. You don't need binoculars. Just get out with your 2 eyes or your 1 eye. If something happened, that's unfortunate, but get out anyway. And look up. Do it. It's fun.
Even the gnarly shipwreck captains can have fun up.
Yeah, they get the best views out there in the middle of the ocean, even with one eye.
That's right.
Well, Will, there's the one thing that I feel anyone who buys a telescope, they're going to need to know how to do it. I didn't know how to do it until you showed me how to do it. In fact, it's how to collimate the mirrors. So I would like you to give us a demonstration, if you would.
Yeah, absolutely. Let's do it.
All right.
So when you're collimating a telescope, yeah, there's basically a couple of different ways to do it. The way I like to do it is with a laser collimator, and you can pick one of these up online for I think about $100 or so bucks. It's definitely worth the price tag because it does the job for you in no time. There are a couple of cheaper options with Cheshire eyepieces in the $30 to $40 range, where you basically put the eyepiece in the focuser and use your eye to make sure the mirrors are aligned. When you're collimating a scope, it's really simple what you're actually doing. With a daub like this, you're basically taking the bottom mirror and the top mirror and pointing them directly at each other, and to make them in a column. That's why they call it collimation. You're putting the light cone in a column. So there's a very precise way to do that, and we're going to use this is actually a Hotech laser collimator, and it's 2-inch, so it fits right in the focuser, so we'll do that. You'll want to point on a laser collimator like this. This is the little window. This is the return window, I'll call it. And you're going to want to point that down toward the bottom of the telescope, because at some point you're going to be at the back of the scope looking at this little window. So you put it in here, and this collimator is really nice. It has compression rings, so it centers itself in the eyepiece holder. You don't have to actually try to center it. And now it's in there. One thing I like to do, and I don't know if it actually makes a difference or not, somebody out there may know, is I like to keep the focuser, which is this assembly here, I like to keep it out about the same distance that I'm going to put an eyepiece in there. That way, when I'm lining the mirrors, everything is about where it's going to be for where my eyepiece will be. So you turn these laser collimators on by twisting the end cap, and now we have a laser down here. You can see in here we're now bouncing a laser off, and so this is going to help us align the mirrors. So let's okay. When you're doing a laser collimation, the first place you want to start is the secondary mirror, which is this mirror up here. Alright, so this is basically what we're looking at. You can see the primary mirror down here, and you can see the laser. You can see the secondary mirror, which is this cell right here, and this is the one we're going to adjust. Now there's 3 adjustment screws here. I've added these knobs on aftermarket. They're called Bob's knobs. Best 30 bucks you'll ever spend. So what I'm basically trying to do is, if you look down there, you'll see the laser dot, and then you can see the donut, which is, I don't know, is it showing up in there? It's in this region here. And what we want to do, see the donut now. So we want to get that laser right there, right in the center of that donut. That's the exact center of our mirror. So the way I do this is I take one of these 3 knobs right here, and you just pick one and you start turning, and you'll see that the little guy start moving around here. Just grab one until it stops working, and then every once in a while I'll grab the actual outside of the secondary and help it get where it needs to be. You don't want to wrench down too hard on those little screws, you'll end up breaking something. Okay, that's pretty good. So you can see, I mean, basically all I did was put the laser right in the middle of that donut, and it's pretty close. That took me all of, what, 30 seconds there. So it's a really quick process up front here. And then now what we're going to basically have to do is go to the back of the scope and align the primary mirror with our secondary. So this is the back of the scope, where the magic happens, if you will. My particular scope, I've taken the locking knobs off, which would rest here. Don't really need them, they vibrate out, it's not a big deal. But you can see these 3 black knobs here, and these are actually connected to the primary mirror cell itself through this metal framework here. And so if you look up on the secondary mirror, you can see how there's 2 laser points pretty close to each other. So the mirror actually isn't all that bad. And then you can look up here in the window and you can actually see the laser is almost in the center hole, which is where we want it. So what I'm going to do is I'm going to start grabbing these little knobs here, and you can see that when I turn a knob, that point of light actually moves around pretty good. And see, I grab this knob, see how it's giving me almost where I need to go, and then that looks like I can put it right there, and I can fine tune it here. And so now if you look in the window up top, you don't see a laser light, you just see the diffusion that comes off of a laser when you're hitting a mirror. So there's a lot of that. And if I take one of these knobs and I just turn it, you can see how the laser needs to sit right in the middle. That's pretty good, actually. And if you look on the secondary right here, you'll see that there is now one laser dot. There is not 2 like there was. And so what we can surmise is since the laser collimator is producing the beam is coming out of the laser collimator, hitting the secondary, comes down and hits the primary, and then it goes back up this way. If all of that is one dot, right, then all the mirrors should be in a column. And so technically, if I take that collimator out and put an eyepiece in, I should be able to put it on a star and I should be good to go. One thing that you might have on your telescope is the locking knobs. They might be here, they might be right next to the adjustment screws themselves. Once you get it to this position, go ahead and lock them down very gently, and your mirror will stay there basically all night. And you may only have to collimate once or twice over a full night if the temperature's pretty steady and everything is hunky-dory. Other than that, I mean, that's basically how you collimate a telescope, at least a Newtonian reflector. When you start getting into the Cassegrain telescopes and refracting telescopes, collimating them is a little bit more involved, but we won't go into that. But this is the most common type of telescope you're going to see. So collimating one like this is pretty simple. It takes less than a few minutes, and you're ready to rock all night long, more than likely.